So there are three essential words for this talk: rapid societal and transformation, because the message from world leaders and non-governmental organisations is clear. If we want to address existential threats like climate change, or if we want to achieve the United Nations Sustainable Development Goals for peace, equality and social justice, then rapid societal transformation is necessary. But the message from sociologists, technologists and nerdy profs like me is equally clear. Advances in digital technologies, such as artificial intelligence, big data and the Internet of Things, have changed the world at a scale and pace that is perhaps unparalleled in human history. So rapid societal transformation is possible. Therefore, applying some good old-fashioned AI logic to the two messages, we see that rapid societal transformation is necessary and rapid societal transformation is possible. But in order to align the two, we need to harness and steer these digital technologies in directions that we choose, to ensure that the societal transformations that they will inevitably produce are indeed the societal transformations of the kind that we actually want. So to harness and steer a digital technology, we need to examine what artificial intelligence can do for us, which we do want, and then to examine what artificial intelligence can do to us, and which we don't want. And this is the essence of the moral-immoral dichotomy of design with artificial intelligence. Because algorithms and digital technologies, like all technology, are not inherently good or bad. It is only the uses to which they are put that have impacts and outcomes that can be judged good or bad. And these impacts can be unintended consequences, which is still no excuse for not trying to think things through. But the societal impact of technology can also be the product of design, and design is never neutral. And this is why, on the one hand, AI can be a positive force for pro-social good and can be designed to enhance qualitative human values such as sustainability and justice, and empower citizen participation and legitimate governance. But on the other hand, AI can have detrimental negative impacts and can be designed to commodify human values and undermine critical thinking, and can diminish the nature of humanity and even what it means to be human. So the biggest engineering challenge in bringing about societal transformation is to solve collective action situations in the context of wicked problems. Collective action situation is one where a group of people need to make common cause in order to achieve a shared objective. Now, it would be more beneficial for the group as a whole if they cooperated, but due to conflicting or competing individual interests, they fail to do so. Now, a wicked problem is a societal problem whose complexity and continually changing requirements means there is not necessarily an obvious terminating condition. Sustainability is a good example. I don't recommend this, but you can jump out of a window and halfway down you can still be thinking it's okay so far. But this is the thing about sustainability. It can look okay until it isn't. Now, nobody expected COBOL programs written in the 70s and 80s to still be running 30, 40, even 50 years later. But these programs are solving the same problem over and over again. They're immutable and monolithic and frankly a bit dumb. But in developing long-lasting systems to solve wicked problems, we need software which can adapt to different operating conditions and consist of many modular units which can be composed, decomposed and recomposed and demonstrate some degree of individual and collective intelligence. So that's our claim. Now, so where is the proof of that? Well, we've frequently encountered issues of collective action and open-endedness when addressing the problem of resource allocation in computer networks and other distributed systems. So it turns out we were trying to solve a sustainable common pool resource management problem. Common pool resource management is a type of collective action problem where a number of independent actors have to share and make use of a common resource, like a field for grazing or water for irrigation, or energy from renewable resources. There are lots of questions here like, how do you decide who gets how much? How do you stop somebody from taking too much? How do you stop someone from free riding by taking resources but not providing any? How do you do all this without some external authority or some centralised component telling all the others what to do? Now, I do know that Imperial College does have a bit of a reputation for preferring equations to people, so it might be considered a bit odd for someone who's been at Imperial for over 30 years to ask, how do people solve this sort of problem? Okay, how do people solve this sort of problem? Well, if we look at the social science literature in the 1960s, there were two important theoretical results about common pool resource management. One said that people would not cooperate at scale unless there was some coercion. The other said that people would destroy a common pool resource by overuse in the short term, even if that was in no one's interest in the long term. And this was called the tragedy of the commons. However, in 1990, the extensive fieldwork of Ellen Ostrom, an American political and economic scientist, showed empirically that the tragedy of commons was not the inevitable outcome that was predicted theoretically. Turns out that human beings are great at making stuff up. Just as we make up stories, we also make up conventional rules. And we have to do this, otherwise we'd never play games. But it turns out we can also make up conventional rules to make sure that we can do sustainable common pool resource management. So Ostrom inferred that sustainability of common pool resources was due to the formalisation of sets of conventional rules in what she called self-governing institutions. These specified constraints on people's behaviour that were mutually agreed, voluntarily monitored and collectively enforced. However, it's not just the institution per se that made the difference. The institutions had to exhibit 8 distinctive features for successful sustainability, and this did not occur if one of the features was missing. So Ostrom then went one step further and recommended that whenever faced with a CPR problem, instead of hoping to evolve an institution with the necessary features, you should design or supply an institution with those features already present. So she converted these features into what she called institutional design principles. And the key contribution of our work was to re-express these institutional design principles as code. And we could then implement communities or societies of intelligent autonomous software agents, which could execute these principles as code and could also sustain a common pool resource. But again, it turned out, provided all the rules were in place. We applied this in sensor networks, where the sensors pool battery power, bandwidth, CPU time, and so on, and in cloud computing, where there is a trade-off between quality of service and total cost of ownership. The critical feature in both applications was self-organisation. The agents themselves were deciding their conventional rules of resource allocation dynamically or on the fly by themselves. And this was so successful that for a while I started seeing everything as a collective action problem. And the only meta problem with that is if your only tool is an Ostrom-shaped hammer, then every problem is a collective action-shaped nail. But the meta solution is that by formalising Ostrom theories from the real world to build intelligent systems for the digital world, it turned out we could use those intelligent systems to develop such solutions for the real world too. But then it turns out just because you can sustain a common pool resource doesn't necessarily mean that the distribution of those resources is fair. But then what exactly do you mean by fair? So if we look again at the social science literature, there are many theories and definitions of fairness, for example, proportional, equitable, envy-free, efficient, and so on. There are also many metrics for measuring fairness, such as the Gini index, and many confounding factors, such as the trade-off between cost and time. You can come up with the fairest solution in the universe, but it will not help if your algorithm is NP complete, and that universe is going to terminate before your algorithm does. However, one time in the office of my friend and colleague Professor Andrew Jones, who's an analytic philosopher from King's College in London, I found in his bookshelves a thin tome by the logician Nicholas Rescher. This book was simply entitled Distributive Justice. And in this book, Rescher observed that distributive justice has, throughout history, consisted in treating people wholly or primarily according to one of 7 canons, where a canon in this context is an established principle established in informal language. These 7 canons of distributive justice were equality, need, ability, effort, productivity, social utility, and supply and demand. Rescher argued that each canon taken in isolation was inadequate as the sole dispensary of distributive justice. Instead, his position was that distributive justice was to be found in people's standing with respect to legitimate claims, both positive and negative. And this, Rescher claimed, placed the emphasis for distributive justice onto 3 questions. Firstly, establishing what legitimate claims are relevant in a specific context. Secondly, working out how they are accommodated in case of plurality. And thirdly, working out how they can be reconciled in cases of conflict. So fair's fair, as they say, without of course ever saying what fair actually means, but we did then unto Rescher what we had done unto Ostrom, and specified and implemented an algorithmic form of the theory. Now, with canons as code, we applied this to a group of agents who had to manage a common pool resource in an economy of scarcity with indivisible goods. So in an economy of scarcity, it means that there are not enough resources for everyone to get what they wanted. And with indivisible goods, you had to get everything you wanted, or the fraction that you did get was worthless. And this means that in any one distribution of resources, it would not be fair, and there was no metric for showing that it could be fair. But we showed that with agents that could self-organize according to Resch's theory, when you had a series of resource distributions computed one after the other, each of them could be separately unfair, but it could be worked out to be fair over time. So now we have a system where we can change the rules to make it sustainable, where we can change values or the weight that we put on values to make it fair. But then we start running into well-known problems from legal and organisational theory, known as the paradox of self-amendment and the iron law of oligarchy. The paradox of self-amendment, as termed by the philosopher Peter Suber, says that if a rule has an amendment clause, can that clause be used to modify itself? So the rule says, you can always change this rule, so does that mean you can change it to, you can never change this rule? Second problem is this iron law of oligarchy, as posed by the sociologist Robert Michels, which states that in any organisation, if insufficient attention is paid to the process and outcomes of self-modification, then it will inevitably be taken over by a clique who will run it for their own interest and not in the common good. And this is what we call the dilemma of the rules. On the one hand, the rules have to be sufficiently unrestricted to allow freedom of collective action. And on the other hand, the rules have to be sufficiently restricted to resist the iron law of oligarchy and prevent the paradox of self-amendment. And this is a question of governance. So the West is the best, as we know, so the best system of governance is liberal democracy. And democracy is a bunch of Athenians doing one man, one vote in the agora, right? Wrong. So Professor Josiah Ober, who's a political scientist and classicist from Stanford University, tells a very different story. Ober showed how Athenian democracy massively outperformed its rival city-states economically, architecturally, militarily and diplomatically on a number of independent metrics, despite a relative parity in territorial size, population density, level of cultural development and availability of mineral resources. And Ober attributed the exceptional success of Athenian democracy to the greater social benefits derived from high levels of cooperation. And this was based on the Athenian superior capacity for resolving public collective action problems. And this was a product of special features of their participatory and deliberative model of self-governance. One of the most important of these special features was the distinctive Athenian system for organising useful knowledge for socially productive purposes. So of course, I tried formalising that Athenian system in an algorithmic framework for automating what's called interactional justice, showing how partial knowledge and subjective assessments can be aggregated into collective knowledge and an objective assessment. And this enabled a form of reflexivity. A system could reflect on its own performance and decide if self-modification of the rules is required or not. Moreover, Ober had another theory, a theory he called basic democracy as opposed to liberal democracy. And the essence of basic democracy was to work out how a group of people could self-organise themselves to avoid tyranny in all its various forms. To do this, he worked out and described a thought experiment called Demopolis. Now, Demopolis imagined a number of people with a preference for avoiding tyranny who were given an island or a city-state and asked how would they go about establishing a robust, long-lasting and legitimate form of democratic governance. Now, of course, a thought experiment, you can't really do that in practice, but you can approximate it with artificial intelligence. And this is what I did. I wrote a simulator for the thought experiment and showed how a group of intelligent agents could design and implement a basic democracy. And one of the conclusions that followed from this work was the idea of democracy by design. If you are designing a system that requires some form of governance, don't just build a system and try to bolt on the democracy afterwards. Design the system with democracy as a primary requirement. And this was known as democracy as code. Now, it also turns out that you can use the principles of democracy by design as an analytic tool. Unfortunately, I have to tell you this. If you look at the UK Parliament and system of governance and wonder if it was designed according to the 8 principles of democracy by design, you would think that the UK is a failing state. And then in terms of where we want to be in 2040, AI in particular, but digital technologies in general, have also been used to undermine collective action, to exacerbate social injustice, and to undermine effective knowledge management. And as I said, to diminish the idea of what it really means to be human. Because when we look at collective action, what do we see? We see the private ownership and control of the means of social coordination and peer production and digital innovation, with little public oversight, little accountability, and no transparency. And this has led to a global monopoly of just a few platforms, each of which dominates a sector of commerce and social life, and also led to what we call the privatization of invention. With respect to social justice, this monopoly has produced an asymmetric distribution of benefits and the rise of surveillance capitalism. This has led to a reduction in opportunities for successful collective action at scale, as well as opportunities for unscrupulous manipulation in pursuit of a hidden agenda, the concentration of political influence in intermediaries, who are often located beyond national governments, and the growth of unearned income by those same intermediaries. In terms of knowledge management, we see the domination of both information sources and communication channels, an unequal distribution of knowledge fostering distrust of reputable source and expertise, the elimination of diversity through polarization and fragmentation, an algorithmic reinforcement of confirmation bias through filter bubbles. And the way that humanity is changing, we argue, it changes the way that we go about arguing, the way that we think, and the way that we hold each other accountable. For accountability, I've talked about DDOS. And this isn't an acronym in this context for distributed denial of service. It means deliberate denial of satire. Satire has been used proactively throughout human history as a means of mocking the pomposity and pretension of others. But it's being seriously undermined by deepfake videos, because if what is fake can be made to be seen as real, then what is real can simply be made to seen as fake and dismissed as such. When it comes to outsourcing cognitive and critical thinking skills, we are doing this all the time to voice-activated virtual assistants. Draw your attention to the article by Jeff Robbins with the analogy of the jewel wasp, which injects its prey with dopamine while it lays an egg which hatches inside it. It doesn't have to be like this. Let's suppose you're aware of a burning issue of social injustice or climate change. For example, inequality in food distribution, how supermarkets and restaurants throw away unsold food, but some children, people in homeless shelters and women's refuges go hungry. Or we all buy stuff which is wrapped in single-use plastic, as much as some of us try not to. And the result is that oceans are choking to death. Now you might think as a single person you can't make a difference. You might think that if there were enough of you, though, you could. You might wonder how you could get together, but for a myriad of reasons that we've just discussed, you don't want to use one of the big global platforms. And you don't want really to wait around for someone to nudge you or to nudge enough of you to force you to act. But suppose there was a platform that you could go from a software repository like GitHub, and you could download this platform, and this platform had 8 specific features. It has openness, it's open source, it's non-profit, there's no advertising, and it's owned by a trust. It has some form of codification. This platform is more like a multi-tool Swiss Army knife. You can also download, configure, and install a range of additional tools called plugins. And these plugins are used to codify the deep social knowledge of Ostrom on sustainability, Rescher on justice, and Ober on governance, and much more besides. It has generativity. You can customize your platform to look, feel, and work the way you want it to. And you can use a tool to build a tool that perhaps the designers of the original tool didn't anticipate or have in mind. There's some common pool resource things going on. There's a horde of programmers actually writing these plugins, working for fun and for the common good. And they're actually using their own instance of this platform to coordinate the production of these plugins. We have decentralization, so you can run your own platform. It runs on a Raspberry Pi in your own home. So now you have your own server, so you can keep your own data and your own identity within your own boundaries. And you determine how much of this you want to reveal or release. You can have visualization. Suddenly you can realize when you get your friends and your family and your colleagues to start working with you, you can see how each of your individual actions may not look like much on its own, but how the collection of small action contributes to a much larger action, which has a greater and more substantial effect that we can actually see. Then there's this notion of what I call park runification for those of you who like to run in parks. Somebody else sees your platform and they see the good that it is doing. And they think to themselves, well, I'll have some of that. And they can, because something else you've done is that you've uploaded your customized version of the platform back to the repository. And these other people can download it from there. And you've performed a public good again because you've lowered the barriers to entry so that other people can get going quickly and easily. And finally, it's all transparent because all the protocols and programming interfaces are open and standard. You can belong to many different platforms but access them seamlessly all from the same app. And in the sum, there's an ecosystem. Anyone can link to your platform and so can many more. And before long, we have an ecosystem of these platforms. And then no one can own this because no one can buy the ecosystem. And this ecosystem of platforms can help us protect our own ecosystem, protect ourselves, and protect our environment. So ultimately, this is the vision, and this is the platform we're developing. Turns out there are many theories from the social sciences, and those theories offer a deep repository of human knowledge. And what we're trying to do is turn that knowledge into logic, and then turn that logic into code, and turn that code into platforms that people can use for sustainability and social justice. Now, it turns out that the last wave of logic-based AI ended in the mid-1980s. The new wave of interest in AI and machine learning started around 2015. And the 30 years in between, well, that was my career. But one thing I've learned is that none of us can work in isolation from each other or from the society in which we're embedded. And we have to take into account and take responsibility for the impact that our work and our algorithms may have on society. But then this is exactly how we will bring about the rapid societal transformations of the kind that we actually want. Thank you very much, and do stay safe.
Thank you so much, Jeremy. It was extremely interesting to hear how you are using these rules from sociology and adding them to the world of artificial intelligence to encourage better living for the many. So I have a couple of questions that have come in from beforehand from the audience. I think the first one is, these systems you're proposing are built on fairness and justice make a lot of sense. Why are they not built into current existing platforms? And what are the barriers?
Well, it's nice that they make some sense. I suppose one possible answer to that is that my parents named me after the gloomy prophet in the Bible, but like many prophets, I'm just not going to be believed. The more serious concern perhaps might be that one of the effects of the design of the internet was that you get this concentration of monopolies at the application layer as a result of preferential attachment and that sort of thing. And that's actually created some very powerful economic interests. And of course, that actually some of the proposals that are in my talk are a bit subversive and actually challenging those very interests themselves.
And another question is, as we're codifying these social values into AI, are we in a way also adding additional bias to them? You said that the Ostrom tools for the collective action problems did not work for all issues. So what is your thought there?
I think, if I understand the question right, we're removing bias. The Ostrom principles, they needed to all be in place for the common pool resource to be sustained, and if some of them were missing, then it wasn't possible to maintain the resource. It wasn't a product of bias. So I think actually getting everything in is removing bias, not adding to it.
Fantastic. And then Marcelo has asked a question here on what could be the impact of this technology in urban design. So what is your vision for that?
So this is what we're trying to do with smart cities, for example. If I understand the question, I'd like to think that it would be complementary to this kind of thing, because sometimes I see people designing smart cities and it's very much a technology first kind of thing. So, oh, we can do this sort of technology. And not so much actually thinking of this as designing something that actually that people want to live and need to live together, and how they can actually do that living together in some ways better. And so the kind of applications that we're thinking of are all these sort of things which can provide these sort of benefits. So you mentioned some in the introduction, which was kind of you, but working to improve air quality, for example, without having to have a pandemic to make it happen. To address issues of energy poverty and food distribution, for example. And so these would all be contributions to improving quality of urban life.
So what are the best ways that governments and organizations can take advantage of this knowledge that you created in your work, and how do you imagine it beyond what you said now with smart cities actually being used?
There's something quite deep going on here, because there's a lot of factors that you have to take into account. So one of them, of course, is basic economics. There's another thing about education that has to be considered in terms of actually sort of making sure that people going through the education system are fully aware of their responsibilities as citizens, but also what digital technologies can do to them. There's something quite lacking in terms of the checks and balances at quite a high level, because one of the things that we're seeing is the aggregation of sort of almost unearned economic power, which is beyond state control. But at the same time, we're also seeing an aggregation of state power that is beyond citizen control. And so you have a significant problem when you have weak national governments which are not able to enforce taxation in a strong and systematic way.
Fantastic. And I think we have another question that's coming. So it's from Stephen, who says, looking at the analogy between governance of societal systems and the more micro governance of largely unsupervised self-learning systems, could your methods inform how we delineate the parameters that the self-learning systems are allowed to learn and act within? And can the human intent behind defining this be codified into the structure?
Taking the first question, thanks very much for this question, Stephen. Taking the first one, there's something very interesting, something that we refer to as reflexive governance. So this is the idea that any system that has to, any control system actually has to have a model of itself. And in particular, there are various different dimensions that that control of social systems takes place across. And it defines a very, very large possible space. And that it's a sort of space that there's not one solution, there's no silver bullet. It really depends on a lot of contextual factors. And the key thing is not to lose, get sucked into the poles of these dimensions and end up in a sink in the physical terms, and not be able to get out of it. So the learning here is not just something that you want to do in a deliberative state, but it's also a meta-deliberative one. So you have to deliberate about your deliberation and being able to understand the trajectories that you're on and where they can go, and then you can do something about it. So that's how I could see the algorithms for machine learning and self-learning here. And can the human intent behind defining this be codified into the my argument is yes. That's the whole point, that I think that we can actually codify this deep social knowledge in such a way that we can produce systems which allow, so I distinguish between self-governance or algorithmic self-governance and algorithmic governance. So algorithmic governance being the idea that the machine determines a set of options and we, the users, are restricted to choosing between them. But algorithmic self-governance means that there's assistance going on. It's a difference between a control technology and an assistive technology.
Fantastic. I think we'll take one more question and then we'll move on to the round table. So I quite like Sandy's question here, which is, if you could reboot the whole internet, would you?
In the interest of time, yes.
And how?
With some difficulty. I think it's very hard to put the genie back in the bottle. And this is one of the principles of, in fact, democracy by design. You don't try to reinvent something, you prevent it from going wrong in the first place. So I think we have a lot of work to do. But for me, the ideal solution now would be for scientists and technologists to work in conjunction with regulators to try to produce a backdated version of the internet. And there's some simple things that we could do to start off with, but one of them would just be to ban advertising on the internet. I mean, you take away the revenue stream, you take away the profit motive, which is the source of some of the problems that we're seeing.
We had someone at Tech Foresight last year proposing to pay more for the internet, so we didn't have to have advertising.
It's another solution, yeah. The thing is, sorry, yeah, just to finish, but I mean, the thing is, it is a great public good, and it was produced as a result of a collective action by a large number of scientists, and it can be a force for good. The problem is that we are seeing a lot of private enterprise built on top of a public infrastructure.
Fantastic. I think that's a lovely end for the Q&A.